Hello everyone, I'm Emma Bilhorn, and today I will explain how multiple genotypes can lead to just one phenotype through epistasis. I will be showing this through one example today. So first I will start off by showing the pathway. And in this pathway, we are looking at fur color in snow leopards. So as you can see, the snow leopard can either have white fur, or red fur. So if you look closely, enzyme 1, in order to get white fur, you have to have homozygous recessive. However, if you are heterozygous, then you move on to the next enzyme. And the next enzyme, if you have homozygous recessive again, you would get white fur. But if you have heterozygous or homozygous dominant, then you will have red fur. So you could have multiple different genotypes and still get white fur, and then multiple different genotypes and still get red fur. But you have to have those two dominant ones in order to get red fur. And white fur is a little more complicated. And I'll explain that through some Punnett squares. So as you can see, we're going to show one cross. The first one is heterozygous diploid cross. And in this cross, we can have 16 different genotypes, and 4 of those genotypes will give us a red fur leopard, and 5 of these genotypes will give us a white fur leopard. So 5 different genotypes, but all the same phenotype, and 4 different genotypes, all the same phenotype. And it's the same one for this. This cross is a little smaller. You only have 4 different genotypes. 3 of them will give us white fur, and 1 of them will give us red fur. And we'll go into a little more depth in this Punnett square. This Punnett square shows all of the different phenotypes. And as we can see, 9 of these genotypes will give us red fur, and 7 of these genotypes will give us white fur. And in this one genotype will give us red fur, and 3 genotypes will give us white fur. So we got 9-to-7 ratio and a 1-to-3 ratio for these 2 crosses. How is this possible? Let's look. So as we can see, for this one, say we have our first one in the Punnett square, we see big A, big A, big B, big B. And if we look, big A moves on, big B, red fur. And we look at a white fur example, and we see little b, little a, big B, big B. So we look, and we have little a, white fur. Even though we have those 2 homozygous dominant alleles, it doesn't matter because we had recessive on the first enzyme. So those are a couple of examples, and similar examples show up in the other one. There's the same genotypes in each one. So then we go to our types of epistasis, and we look and we see there's the 9-to-7 ratio in the dihybrid heterozygous cross, and that means we have a duplicate recessive epistasis for our 9 red leopards and 7 white leopards. So I hope that shows you a little bit more about how multiple genotypes can lead to the same phenotype.